Assalamu alaikum, my dear students. I hope all of you are fine and having good health. In our today's topic, we will discuss about the allotropy. Mainly allotropy, it is the property of solids. When we talk about the solids, mainly by definition, allotropy is the existence of an element in more than one crystalline form. When element is going to be exist in more than one crystalline form, then this property of the solid we called it as the allotropy. And all the different forms, all the different forms of the element, we call these forms as the allotropes, or we can also call it as the allotropic forms, allotropes or the allotropic forms. So this is the mainly property of the solids, that an element that is in the solid state, it can exist in more than crystalline form or crystalline solids. This is known as the allotropy. In this picture you can see that we have the allotropes of sulfur. Here we have the allotropes rhombic sulfur, and the second we have the monoclinic sulfur. So this is the first one allotropic form and the second allotropic form of the sulfur, rhombic and monoclinic. Here there is a just difference, or the structure or the arrangement of the particles is different, just, but it is just a sulfur. We have just the difference of their particles arrangement. The next we have, what are the main reasons for the allotropes of an element, that why the allotropic forms of an element can exist. The first reason for the allotropic forms of an element is that an element can exist in more than one physical state. It depends upon the physical state of an element. That an element can exist in more than physical state. For example, we have a carbon. It can exist in the form of diamond. It can exist in the form of kajal. It can exist in the form of graphite. All these are the different states or the physical states of the carbon, and these are known as its allotropes. So allotropes may exist due to the different physical states of an element. Next we have the second property or second reason that why the allotropes are exist, the existence of two or more kind of molecules, that there is the existence of one or more molecules of an element. For example, we have oxygen. When we talk about the oxygen, we just see that the oxygen can exist in O2 form, and it can also exist in O3 form. Here it is the oxygen gas, and here O3, it is the ozone layer. So this is due to the different molecules that an element can have. Here the oxygen have O2 two atoms in one molecule, and here it has three atoms in a molecule. So this is due to the molecule has different number of atoms in it. Next we have the third reason for this, that why the allotropic forms exist. This is due to the different arrangement of the atoms, due to the different arrangement of atoms or molecules. When the molecules or atoms are arranged differently, then there may be allotropic forms of that element or a compound. For example, if we have a sulfur, as I have just explained earlier, it exists in two allotropic forms. The first one is monoclinic, and the second one was rhombic, or we can also call it as orthorhombic or simple rhombic sulfur. So this is due to the different arrangement of the atoms or the molecules of that element. So mainly we have just three reasons for the allotropes of an element to be exist over there. Next we have the term transition temperature, that is very important from point of view of the allotropes. Basically transition temperature, it is the temperature at which one allotropic form of an element is converted into another form or another allotropic form. That temperature we called it as the transition temperature. Now, for example, we have sulfur. It's S8 and it is going to be changed into the another allotropic form. We have rhombic sulfur and here we have the monoclinic sulfur. The temperature at which these two forms coexist with each other, it is known as the transition temperature, and the temperature for the sulfur we have 95.5 degrees Celsius. At this temperature, the rhombic will be changes into the monoclinic, and if it is in the form of monoclinic, it will be converted into the rhombic sulfur. Next we have the other example, it is tin. You can write it as gray tin. It is converted into white tin, and here the transition temperature we have it is 13.2 degrees Celsius. Here its structure is cubic and in white tin is having the structure tetragonal. So this is about the transition temperature, simply one allotropic form converted into another allotropic form. Next we have some examples of the allotropes here. For example, we have carbon, we have oxygen, we have sulfur, and many more. Carbon can exist in the form of diamond, graphite. Oxygen can exist in the form of O2 and O3, and sulfur can exist in the form of rhombic. And the second state is monoclinic. So all these are the examples for the allotropes. I hope you guys understand, and if you have any queries you may ask me about in the comment section, and in the next video we will detail studied about the allotropes of the carbon. For that time, have a good day and Allah Hafiz.